Okay, almost this is the final important topic of the electricity section, because after that we already discussed the derivation of resistors in parallel and series. So that is actually the part of DC, but that was a simple example or the simple concept. So that's why we solved that concept with the electricity. Okay, do you have your updated syllabus file in PDF?
Yeah, it was okay.
Okay, so you may just check the topics also, that if you have any confusion, if you want to ask anything, so you may ask according to the syllabus. And I also shared the PDF books, so that will also help you to read the topics for the reference, right? And in 1 or 2 day, I will also share all the PDF notes in the written form also, so that will also help you for your notes. So this is the last new concept that is related to DC circuit. Otherwise, the remaining is potential difference or potential divider. So that is also an old topic, and you already have concept about that. So last topic is Kirchhoff's first rule and Kirchhoff's second rule for current and voltage.
Okay.
So Kirchhoff is the name of the scientist actually that this discover this concept related to current and voltage in series and parallel, that how to find out the current and how to find out the voltage, or how the value of current and voltage vary when current or voltage is pass, or it's actually dividing into the junctions in series and parallel combination. So first of all, we need to talk about the first law. So the statement of first law is very simple. Statements are very simple. The statement states that the sum of current entering a junction always equal to the sum of currents out of the junction. Simple word, right? So the sum of the currents entering a junction always equal to the sum of out of the junction, right?
Yep.
So this is the concept of Kirchhoff's first rule, right? And if we want to define what is junction, what is a branch, so let's suppose if we first talk about the junction. So junction term is also used on the railway tracks for a specific station, that this junction or that junction. So actually it is a point where at least three circuit, or we can say that three different path actually connects, right? So it is a point where at least path meets, right? And if we talk about only two connections or two circuits connection, so we can say that that two connection path is known as a branch. Path connecting two junctions, right? So this is the difference between junction and the branch. And according to the first law of Kirchhoff, the statement is very simple. So first law is equals to that the total current Or we can say that, let's suppose if current is moving from one point and then it divides into three or more than three parts, so it will be equal to the sum of all the currents, I1, I2, 3, like this. And if we just want to draw a diagram, so it will be a very simple one. Like current is moving from this direction and adds into three paths. This one. Okay. So our resultant current or value of current is equals to the sum of all individual value of currents passing through I1, I2, I3, right? And we
It's like
already,
IGCSE, but like the only difference is we know what it's called now.
yes, that is already the same concept. So now you already got the concept that how to add the values of current. In parallel combination, a current actually divides. In series combination, the current remains same, right? So that is the
Yeah.
only difference again. And that is also for the second, that's Kirchhoff's second rule. And it will be the Kirchhoff's second or second law about. It is for the voltage only, right? EMF. So first one is the for the current. Second one is for the EMF. So the sum of the EMF in a closed circuits, there is a difference. You can see that in second law we are writing closed circuit. Close, why closed circuit? Because we are actually describing the series combination, right? Because we know it actually divides in series combination. So that's why we use the concept of closed circuit is in second law for EMF. And in the first one, we are using the concept of junction, that is the parallel, because now current is actually moving in the parallel path, right? So again, the same concept that we already discussed in the topic of resistance, right?
Yeah.
The sum of the potential difference. Because we know EMF is related to the battery, connected with the battery, and potential difference are actually with the components. So that's why there is a difference between EMF and potential difference always. So if you want to write the, so your equation will be, let's suppose if we are having two different sources, so EMF1, EMF2, so we combine them and then get the total of the potential difference on the other side, right? Like we just combine two cells, so EMF of first cell, EMF of second cell in series, and then it is connected with two lamps. So we just put two voltmeter in parallel with two loads. So that's why V1 plus V2. Okay.
Okay.
And you know the same concept again in series, it will divide, and in parallel combination, it will remain same. Okay. So any confusion?
No, it's pretty simple.
Okay. Okay, let's suppose if we consider example for Kirchhoff's second rule first, because that is voltage, the current is not very difficult. Suppose if we consider one circuit, we are having a power source and we just connected with the wires. There is a lamp connected over here. Then there will be a connection. Okay, so these are connections, connect the components. Is our final component in the circuit, and these empty circles actually are the voltmeter. Let's suppose this will be V1, this will be V2, this will be RV, and the remaining values 24 volt is for the EMF. And on the left hand side, we are having 2 volt lamp connected, 12 volt lamp connected, 8 volt, and all of the things are unknown, right? So actually what we need to calculate, we need to find out the values of the reading on the voltmeter V1, V2, and V3, right? And all the lamps and the resistors have the same resistance, right? So all resistors have the same value, right? So this is the whole circuit, and we need to find out what? We need to find out the value of V1, V2, V3. So these are the unknown value you need to calculate. All resistance and all the lamps has the same value, right? So how we start? Let's suppose if we first want to solve for the first voltmeter V1. So any idea how to start to solve for the first voltmeter, that is V1?
Okay, so we know that there's 24 volts in total, right? And it has to like split apart, right?
Okay.
So 12. So are 12 volts going to like one of the lamps or what?
Hmm.
And then
Okay.
2 volts to
Yes.
another lamp? 22 is gonna be left after passing through the 2 volts. And then 1, 2, 3, there are 3 different junctions. So you're gonna do like 22 divided by 3.
Hmm. So let's suppose if
Okay.
we just want to find out the value for V1, so we just cut out the specific part from the circuit. So it means that let's suppose if we consider the path like this. So this is the specific part which we need to solve first, right? For V1. The very first part, what we need to do, we know that this is related to the voltage because we are going to find out the voltage. So we need to apply Kirchhoff's second law, right? The sum of three component is equals to the EMF, right?
Yep.
We just simply need to apply rule number 2. So 24 volts will be equal to uh, 2 volts, right? Plus 1, that is unknown, plus 12 volts, right?
Yeah.
And 1 will be equal to finally 24 minus 12 minus 2. So that is 10 volts. So this is the first part. And what to do for the second one? So V1 is equals to 10 volts. We know that.
Yeah, and then what we're gonna do is
Hmm.
we know that 2 plus 10 plus 12, so like 24 has been gone through like in the first one. So in the second one, are we also gonna get like
Yes, we can use the same concept because that is also in parallel combination with the EMF or the battery, right? So if we just split again the second circuit, so that will make easy for us to first find the value.
yeah, also the lamps will have the same like uh they're the same type of lamps, so we can just do like 2x.
Yes, yes. So there will be a same lamp connected in the circuit. So we use the same thing. So what we need to do for the second, in second, we know that there is 8 volt connected, right? This one,
Yeah,
right? And 2V is also connected in the circuit because current starts to flow from the left hand side. So this 2 volt is now also connected with 8 volt. So 2 volt, 8 volt plus V2,
and
right? And the
yeah, so then
second lamp
4 minus 10 is gonna give you 14, and then since they're 2v, so then you're gonna like divide it by
divided by
uh,
2.
you
Yes,
get
very
7.
good. 7 means that our value will be equal to 7. So initially we just got the value 14 volt for 2 lamps because there are 2 lamps.
Yeah, of the same
And
type.
yes, and then we divide by 2, so we will get the value only 7 volt, right? And the final, the V3, now
V3,
V3
so
is, hmm,
can we use the same concept?
yes. Now we see concept, we know that 2 volt is connected with directly V3 because they are in series. Because when we talk about 2 volt, that is this lamp and this component. So these are in series. So we know that in series combination, we need to add them. So 2 volt plus V3 is equals to 24. So our final answer will be equal to 22, right?
Because you just did 24 minus 2.
Yes. So 2 volt plus V. So this is the final answer.
Okay, so it's like easy. It's just like step by step solving a puzzle.
Yes. So it will be just like that because we studied the concept. This is the practical application. We can say that that how Kirchhoff's rule helps you to find out the value because the current or to calculate the current value is like the easiest one. We already solved many question, but in voltage, it will be like difficult because circuit is in parallel combination and we need to use the series concept. So that is slightly difficult one. Otherwise, it is not a big deal because you already have good concepts related to that. And the next topic in this chapter is related to the derivation of formula for series resistor combination and parallel resistor combination, right? So you know the concept that we already discussed, that how to derive the formula for series combination, how to derive the formula for parallel combination, right? So now that is not much difficult for you to find out the values, right? Okay.